This is a lesson about time zones, which really, of course, is a lesson about the movements of the Earth. So we start out with index cards, and we have written each time of day on an index card, from 12 p.m., 1 p.m., all the way back around to 12 a.m., 1 a.m., and back to noon again. Then you can play this game inside or outside, and I'll show you both. Here we are taping the index cards to the floor, and you want to make sure that you tape 12 p.m. directly under whatever you're using for a sun, so that students get the idea that 12 p.m. is when the sun is directly overhead. Here we are using a big yellow tissue paper ball that I found at a party store. I have found that the best way to lay out your circle is to start with 12 noon under the sun, and then put 12 a.m. directly across the circle from that. Then put the sixes on the other two sides, and then it's much easier to fill in the other numbers and make the whole thing symmetrical. In this time zone game that we play, each child is one of the 24 time zones. You really do need 24 people to play this game. So sometimes I have to get the assistant principal or another teacher walking by or someone to come in and help us. Next time I do this activity, I think I will have a globe handy with a flashlight. Then, when a particular child, and therefore a place on Earth, is directly under the sun, I can shine the flashlight directly on that spot on the globe, so that they get a better idea how that works and what I mean by directly over.
The sun is shining directly at Chattanooga, Tennessee. It means that it is noon in Chattanooga. Okay? So now let's see what other places in the world, what time it is when it's noon in Chattanooga, Tennessee. Okay? So in Los Angeles, California, it is 9 a.m. when it is noon in Chattanooga, Tennessee. In Alaska, it is 8 a.m. when it is noon in Chattanooga, Tennessee. When it is noon in Chattanooga, Tennessee, it is 5 p.m. in Great Britain. Oh, wow. Okay? Oh, you guys are going to like this one. When it is noon in Chattanooga, Tennessee, it is 7 p.m. in Egypt.
Do it.
Okay? It is 9 p.m. in India. It is 6 a.m. It's 6 in the morning in Hawaii. It is 2 a.m. in Australia. Oh, I'll paper clip yours, Joy. Okay. It is, this one's interesting, when it is 12 p.m., which is noon in Chattanooga, Tennessee, the exact opposite is 12 a.m. in China, Beijing, China. Okay? They are sound asleep.
Now they will all join hands and make one big planet.
But the Earth is a big globe. So in China,
We just talked about shape, so it's a sphere.
it's a sphere.
It's
It's
solid, right? You can't see through it.
Can you
It's
see
not
through the
flat.
Earth? Is it flat? Okay, so it's really big and round. Can China see the sun right now? China, can you see through the Earth to see the sun?
No.
So is it daytime or nighttime in China? Okay, so I want everyone to rotate this way 15 degrees, 1 hour. You only go over 1 hour. 1 hour. So if you look at the note cards behind you, you are going to rotate 1 hour. So that means you're only going to go over 1 note card. That means you're rotating 1 hour. Okay. I would like everyone to use your eyes. Use your eyes, and you are going to look with your eyes at noon. Where is noon? Where is noon located in our Earth right now? How do we know this is noon? Because the sun is shining directly on Colorado, right? So Colorado is noontime. If it's noontime in Colorado, what time is it in Chattanooga, Tennessee? Alex?
No.
Look down.
2 p.m.
2 p.m. Okay, so
That's when we go to science.
that's when you go to science. Okay? Whereas you're in science in Chattanooga, Tennessee, Hawaii, you would just now be arriving to school. Okay? Australia, what time is it?
4 p.m.
4 are you doing at 4 a.m.? Are you sleeping? I'm sleeping at 4 a.m. That's so early in the morning. I'm sleeping, and I'll show you right now. I want everyone to rotate one note card, which equals 1 hour. Ready, go. Rotate. One time. One side. Okay. Hawaii. Are you getting closer to the sun, or are you getting farther away from the sun? Closer to the sun. So do you think that you're going into the daytime or into the nighttime? Into the daytime. Okay, Germany. Are you getting closer to the sun or further away from the sun? Okay, so do you think you're going into the daytime or into the nighttime? Into the nighttime. Tell me what time it is. 9 p.m. So are most of you already asleep at 9 p.m.?
No.
Yes. Okay. See right now. Okay, I want everyone to rotate 3 hours. So that means 3 note cards. Are you ready? Ready, go. 1, 2, 3. Okay, 3. What place in our world is at noon right now? Noon. Hawaii. Why is Hawaii at noon?
Because she's under the sun.
She's directly under the sun. Good job. Okay, China, what time is it where you are? 6 a.m. So you're going to wake up soon in China. Great Britain, what time is it where you are? Great Britain, what time is it where you are? 11 p.m. But you're sound asleep. But China, they're about to wake up. So do you see how all these different things can happen in the world, but at different times?
We used index cards with tape on the back in class this day, but some of them fell off. You can also use address label stickers. You play the game the very same way outside, but there are a couple of tricks that I've learned. First of all, the index cards will blow away. So I laminated all of them to make them a little heavier, and then taped them all to one long piece of string. It also helps me store it. Then you just spread out the time zones in a circle. And here you can see that we have them going in the right order, from noon all the way around. Do make sure that you are having your kid Earth turn in the right direction. Directly across from 12 p.m. is 12 a.m. When you pick this up, in order to keep it from getting tangled, you want to very carefully stack one card on top of the next one. I have found that it will tangle easily if you do not collect it in sort of an accordion style. And then I keep it clipped together and place it in the file cabinet. I also found this wonderful book in our school library. While one kid is going to sleep at 9 o'clock, it tells what other people around the world are doing at the same time. When I really do this with my class, I use some sort of ball for the moon, maybe a styrofoam ball or something that would be an appropriate size compared to the sun. In this video, I've had to Photoshop in a moon and sun because I did not have them handy when I had the index cards spread out on the ground. But there would really be a physical ball to be the moon and sun for them to see as they spin around. When my older students are learning about moon phases, we break out the time zone game again. We review where we would find noon and midnight and all the other times in between. And then we place the moon somewhere. I ask students, do you ever see the moon during the day? How about in the morning? How about in the afternoon? What about at night? And we place the moon somewhere in its orbit. Then, facing out this time, students go around in their circle through their time zones. They see that China will see the moon in the same place, and therefore the same phase, that we would see it in the United States, or Australia, or Germany, or Brazil. It is a common misconception that if we have a full moon, China must be having a new moon that same night, which of course is incorrect. So, students then see that because the moon takes 28 days to go all the way around its orbit, that the moon will be in relatively the same spot for someone seeing it 12 hours after someone else. Finally, hopefully, my students will begin to understand that if you see the moon directly overhead at 3 p.m., it will be the same phase each time. That will be a waxing crescent moon. If, however, you are at 9 o'clock p.m. when the moon is directly overhead, then that will be a waxing gibbous. I also want to make sure they understand that there are, obviously, rise and set times for the moon. When they have spun around to the other side, they will no longer see that 3 p.m. moon in the morning. It will take our moon an entire week to do 1/4 of its orbit. And so, sometimes I have the students spin around several times, several days worth, to see that the moon has not moved a great deal in that period of time. I will try to film the part about the moon phases when I have a whole class to do this activity with. I realize that it is hard to understand, but if you have the students spinning in a circle facing outward, they will spin toward the moon, be directly under the moon, and then be past the moon. And at some point they will be unable to see the moon in its current location. You want them to look down at the time zones that they are in at those different points so that they can see that the moon rises and sets, see about what phase the moon will be when it is directly overhead at certain times of the day. I would love to finish this video with all the correct footage, but I'm running out of room on my iPad, so I have to put it on YouTube now. Please feel free to ask questions if you have any, especially about the moon phase part, and I will try my best to answer them. I will upload the footage when I have it.